So the first question on the exam was to find a function was given f of x is equal to x minus 8 raised to 2 over 3. So I had to find the intercepts, extrema, intervals of increase or decrease, and intervals concavity and points of inflection. So first I proceeded with the intercepts. To find the x and y intercepts, I set x as 0 to find the y. I input it into the equation. I used this property a raised to m over n to separate the m and the 1 over n to make it simpler, the 2 and the 1 over 3. So I solved and got 4. So the coordinate was 0, 4, and I did the same way for x-intercept. So I set y as 0, and since there's an exponent 2 over 3, it makes it harder. So I raised both the sides with the reciprocal, which is 3 over 2. So the left side, the exponents get cancelled. So we would equate to x minus 8 is equal to 0 raised to 3 over 2 is 0. So x minus 8 is equal to 0, x is equal to 8. So the coordinate for this is 8, 0. And next I proceeded to find the extremas and the increase or decrease intervals. So in order to do that, I found the first derivative of the function. I used the formula n x raised to n minus 1, n representing the exponents. So I took the exponent to the front, which is 2 over 3. So 2 over 3 into x minus 8 raised to 2 over 3 minus 1, which is negative 1 over 3. So that was the first derivative. And when does the f prime of x equal to 0, or when it doesn't exist? So since the exponent was a negative, the derivative is undefined at the point x equal to 8. And I've explained it further. It is the function is never equal to 0 because there's a numerator of 2, which would not make it equate to 0. And there's the critical point is at x equal to 8, which determines whether it is either a local maximum or a local minimum. So further, to find the concavity, I found the second derivative. So f prime of x, the second derivative. So I used the first derivative and did the derivative again. So I got 2 over 3 into negative 1 over 3 into x minus 8 raised to negative 4 over 3, which I got this as the final answer, negative 2 over 3 into x minus 8 raised to negative 4 over 3. So I used few points that around the value 8, which was 7 and 9. I inputted 7 into the equation of the second derivative, and I solved and got negative 2 over 9, which was a negative value. And same I did for x, so x is equal to 9, and I solved and received a negative value again. So so the conclusion I've come to is that when a value is smaller than 8, and if it's a negative value, it's a concavity down. So the value here I used was 7. So since it was a negative value, it was a concavity down. Same for the x equal to 9. Since it was a negative value again, it was a concavity down again. So since both were concavity down, there are no inflection points for this function. And here is a rough graph of how the function would look like. So there's a cusp at 8, the coordinate 8, 0, and this is not a concavity up, it's basically a concavity down going towards the point 8, 0, and it'll keep on going further. So since there's a cusp at this point, the slope is undefined. So the next question, the second question is, an aeroplane is traveling south 65 degrees east with a resultant ground speed of 420 kilometers per hour, and there's the nose of the plane is pointing towards the east with an airspeed of 450 kilometers per hour. So I was supposed to find the wind speed and the direction of the wind. So we are given the result in the 65 degrees from south, and I gave the variable w to be to represent the wind speed. So I use the cosine law. W square is equal to 450 square plus 420 square minus 2 450 into 420 into the cos 45. And I solved for it, and I got W as 468.135 kilometers per hour, which is the resultant wind speed. So with the help of the wind speed, I can find the direction. So I used the sine law. So I created this way. The sine law is sine A over A is equal to sine B over B is equal to sine C over C. So here I had to find this theta. So sine theta divided by the resultant ground speed equal to the sine of the 65, the direction, divided by W. Since we have a value for W is equal to sine 65 divided by the value we received, which was W. So it's the same thing. So sine theta is, so I equated for sine theta to find the sine theta, the value of theta, the degree. So it's equal to 420 sine 65 divided by the value we found, which was the direction, the speed, which is equal to 0.8131, which is what I found for sine theta,